Okay, so now let's learn more about angles. For this lesson, we will be learning the different angle relationships. So let's start with congruent angles. Similar to congruent segments, when we say congruent angles, these are angles with equal measurements. Let's have these as an example. We have here angle 1 and angle 2. Using this symbol, we can say that using this symbol, that thick symbol, we can say that the two angles with the same symbol mean that they are congruent or they have the same measurements. So, given this marking, which shows that they are congruent or the same measurement, we can conclude that angle 1 is congruent to angle 2. Let's have another example. We have here angle 3 and angle 4. Another symbol that we use to show congruent angles are the number of curves used for the angles. Let's have angle 3 and angle 4. Looking at these markings, we have double markings for the angles. This means that these two angles, angle 3 and angle 4, have the same measurement. Therefore, given that symbol, we can conclude that angle 3 is congruent to angle 4. Aside from the congruent angles, let's move on with the adjacent angles. When we say adjacent angles, these are angles that share the same vertex and have one side in common between them. Adjacent actually means in Tagalog is magkatabi, magkadikit. So in here, we have angle 5 and angle 6. They are adjacent because they share one common side between them, and that is ray AB. So given that ray AB is the common side of these two angles, we can say that angle 5 and angle 6 are adjacent angles. In Filipino, magkadikit or magkatabi na angles. And for them to be adjacent, they should have a common vertex. And in this case, point B is their common vertex. Let's have another example. We have here angle 7 and angle 8. Their common vertex is point D, while their common side is ray DC. So given that, we can conclude that angle 7 and angle 8 are adjacent angles. Let's move on with complementary angles. When we say complementary angles, the sum of two angle measures is 90 degrees. So therefore, for us to have a complementary angles, when you add the two measurements of the angles, they should be equal to 90 degrees. So let's have this as an example. We have angle 9 and angle 10. So by applying complementary angles concept, we have the measurement of angle 9 plus the measurement of angle 10 is equal to 90 degrees. And take note that since we are talking about measurement, we should not write the degree symbol for the measurement. So, let's have this as an example. If angle 10 is 62 degrees, what do you think is the measurement of angle 9? what measurement will complete the measurement of 90? Okay, so angle 28 should be the measurement of angle 9 because if we add 62 plus 28, the answer will be 90 degrees. So given that idea, we can say that these two angles, angle 9 and angle 10, are complementary angles. Now, complementary angles are not only applicable for adjacent angles, just like our first example. We can also have angles that are not adjacent, just like angle HON and angle EST. They are not adjacent, but they can be complementary. How is that? As long as their sum or the measurement of their sum is 90 degrees, then they are complementary. Let's have this. The measurement of angle HON plus the measurement of angle EST should be equal to 90 since we are talking about complementary angles. So, if the measurement of angle HON is 81 degrees, what do you think is the measurement of angle EST? What measurement will complete to 90 degrees? Okay, so the missing value for this one is, if this is 81 degrees, the missing value for this will be 9 degrees. So that when you add 81 plus 9, the answer will be 90 degrees. So with that, they are considered complementary angles. For complementary angles that's equal to 90, we also have supplementary angles. And when we say supplementary angles, the sum of the two angles should be 180 degrees. So let's have this as an example. We have angle 11 and angle 12. So when we add them, angle 11 plus the measurement of angle 12 is equal to 180. If angle 11 is 58 degrees, what do you think should be the measurement of angle 12? Remember, the sum should be equal to 180. So what measurement will complete the 180-degree measurement for this angle? So the missing value is 122 degrees. So 58 plus 122 will be equal to 180 degrees. Okay? Let's have another example. Again, similarly with the complementary angle, supplementary angles can also be non-adjacent. Our first example shows adjacent angles, while on the other example, they are non-adjacent. Therefore, we can still consider supplementary angles as long as their sum is 180 degrees. Let's have this as an example. If the measurement of angle SIM plus the measurement of angle PLE is equal to 180 degrees, then they are supplementary. So, if the measurement of angle PLE is 11 degrees, what do you think is the measurement of angle SIM? What value will complete the 180-degree measurement? Did you get it? The correct answer is 169 degrees. So when you add 169 plus 11, they will be equal to 180 degrees. So therefore, that makes them supplementary angles. Last will be the linear pair. Actually, from the previous example, we already have shown here an example of a linear pair. From the word itself, linear pair. Pair of angles that will make a line. Which of them? Which of them? Is it the adjacent angles or the non-adjacent angles? Which of them showed the combination of two angles that formed one line? Correct. That is the adjacent angles. So therefore, this is what we consider as the linear pair. Let's have this as an example. When we say linear pair, these are actually two angles that are adjacent. Again, they should be adjacent and supplementary. If they are not adjacent but supplementary, they are not linear pair. They are just supplementary. If they are adjacent but not supplementary, then they are not a linear pair because they are just adjacent. So therefore, for them to be considered linear pair, they should be both adjacent and supplementary. So let's have here as an example. Angle 1 and angle 2 form a linear pair. How is that? There is this line and another ray here that makes two adjacent angles. And where is the line from the word linear pair? The line that was formed is this side. Okay? So therefore, they should be adjacent and supplementary. So if angle 1 and angle 2 form a linear pair, we can say that angle 1, the measurement of angle 1 plus the measurement of angle 2 should be equal to 180 degrees, just like a supplementary, because that is one of the requirements. So if angle 1 is 60 degrees, what do you think will be the measurement of angle 2? Again, they should be supplementary. What measurement will complete the 180 degrees? You're right. So that is 120 degrees. So therefore, since they are adjacent, they have a common vertex, and the common side, the angles have common vertex and common sides, and there is this line that was formed because of this combination of two angles, then we can say that they form a linear pair. Of course, we also have the easiest of all, the vertical angles. Angles opposite each other when two lines intersect are vertical angles. And always remember, vertical angles are always congruent. So what do we mean when we say vertical angles? Angles that are formed by two intersecting lines. And then the lines opposite, the angles opposite each other are called vertical angles. And so therefore they are congruent. If this is 60 degrees, this is also 60 degrees. Oops, but wait. Since we have here adjacent angles that form a linear pair, we can say that these two, angle 3 and 4, form a linear pair. So if this is 60, this is 120 degrees because that will complete the 180 degrees. Okay? And so, again, angle 4 and angle 5 are vertical angles. So if angle 4 is 120 degrees, angle 5 will also be 120 degrees. Got it? So, angle 3, always remember for vertical angles, angle 3 and angle 6 are congruent. You remember the markings for congruent symbols. And of course, if that is 55 degrees, what do you think will be the measurement of angle 6? Of course, it's also 55 degrees. And of course, take note that angle 4 and angle 5 are also vertical angles. Therefore, if angle 3 is 55 degrees and they form a linear pair with angle 4, the sum should be 180. Therefore, what is the missing measurement for angle 4? It's 125 degrees. And since angle 4 is 125 degrees, and it is vertical angle to angle 5, then we can clearly say that the measurement of angle 5 is also 125 degrees. So, how will you check if your answer is correct? If you add the 4 measurements, they should be equal to 360 degrees. Can you follow? And of course, another thing to consider, a linear pair is like your protractor. The total measurement of this should be 180 degrees. So of course, the other side of your semicircle should also be 180 degrees, wherein when you add the two, they will be equal to 360 degrees. So that is the concept of vertical angles. We also have here the angle bisector. Angle bisector is like the midpoint in the segments. Angle bisector divides the angle into two congruent parts. So therefore, we have here EO, this ray EO bisects. When we say bisects, it's another term for divides. So therefore, we can say here that line segment, ray EO bisects angle GEM. And so when it is being bisected and divided into two congruent parts, whatever will be the measurement here will be the measurement here. Can you follow? So let's have here as an example. If GEM or angle GEM is a right angle, we know that a right angle is 90 degrees. And EO is an angle bisector. Therefore, what is the measurement of angle GEO and OEM? Again, the whole measurement here is 90, and that is in our given, the right angle. So if it is being divided into two by ray EO, we can say that GEO is 45 degrees and the angle OEM is also 45 degrees. That is because of the angle bisector, a ray that divides the angle into two congruent parts. Can you follow? So therefore, they are both 45 degrees. Thank you so much. I hope you learned something from our discussion today.